we're given that secant of theta is equal to -5. We want to find cosecant theta and cosine theta, where theta is between pi over 2 and pi. Okay, so let's draw our graph. Pi over 2 to pi is in the second quadrant. So let's say we have second quadrant here. Theta is our angle. Secant theta is -5. We know that secant of theta is 1 over cosine. So if I solve for cosine, I have to flip both sides. So if I flip 1 over cosine, it just becomes cosine. If I flip -5, well, you can think of -5 as -5 over 1. So if I flip that, I get -1 over 5. Okay, so cosine is adjacent over hypotenuse. So the adjacent side is a -1. Hypotenuse is 5. Now let's solve this right triangle. So we have to use the Pythagorean theorem. So we have a squared plus b squared equals c squared. That's -1 squared plus, we'll call this side y. So it'll be y squared equals 5 squared. That's 1 plus y squared equals 25. Y squared is 24. And so y will be the square root of 24. And that'll be 2 root 6. Okay. So technically, you have to do plus or minus. But because we're in the second quadrant, y is positive. Okay, so we'll just leave that as 2 root 6. Okay, now we can finally answer the questions. So cosecant theta, well, cosecant theta is just 1 over sine. Okay, so let's first find out what sine is. Sine is opposite over hypotenuse. So opposite is 2 root 6. Hypotenuse is 5. So when you do 1 over sine, you're just reversing the order. It turns into hypotenuse over opposite. Okay, so that's just going to be the same thing. Hypotenuse over opposite. Well, 1 over opposite over hypotenuse, and that just becomes 5 over 2 root 6. And if you want to rationalize the denominator, you want to multiply the top and bottom by root 6. So we have 5 root 6 over 2 times, well, the root 6 times root 6 is just going to be 6. So 2 times 6 is 12. Okay. So this is your cosecant theta. And then cosine theta, we actually solved over here. That was our -1/5. Okay, so that completes the problem.